Hi, Kent.
Hey,
Good morning.
hey, Mohan, how are you? Good morning.
Great. How are you doing today?
Good, man. We're here at the last chapter of DSFA section in the book.
Yep.
Um, we're going to try to cover the last section of that today. Probably the most important section too, I guess.
Oh, yeah, certainly for the performance standpoint, right?
Yeah, the database, right? The
Yeah.
database itself. Um, we're going to go a little bit more off script today for
Okay.
this section than we have in the past sections. The reason why is because we really, in the book, we tried to just basically stay on topic, even though, 1,220 pages. I guess somebody could argue that we really didn't didn't spare the pages, right? We kind of gave them as much information as we could give them. Um, but we didn't cover application development, right? We didn't cover how to write or configure your application code that's going to interface with a database. You know, buzzwords like cloud and continuous operation and continuous deployment or continuous integration, um, microservices, event-based architectures. These are all terms that have kind of come to the forefront recently, especially when we wrote this book. We really didn't discuss those kinds of things in the book at all. We just simply talked about DB2 and certification for DB2. So for DSFA to work, though, no matter how well you do the database, if the applications aren't written correctly, they won't be able to take advantage of it. It's sort of like the old argument about relational databases. If your application writes all of their SQL with a select star, then none of the applications are relational, even though they're accessing a relational database. They're positional, not relational, because if you change the order of the columns, the select star is going to return the data in a different order.
That's exactly right. Yeah.
Right? So it's no longer relational, it's positional. And so you pretty much violated the whole reason for creating a relational database, in that your applications are not relational at all. Um, so that's the kind of thing we'll be talking a little bit more about today. Also, you and I, in the book, we really didn't get into all of the more modern storage solutions that are out there today. The StorageWise and Smart SAN storage that's available in the world today for people to use. A lot of systems today are built on flash storage or solid state devices. And so, reorgs and location of files and things like that are not quite the same under a memory-based physical file data provider, as it is with spinning disk and rotational delays and repositioning of the heads and all that kind of stuff is different with spinning disk than it is with solid state devices and flash storage. So, but the techniques that are in here, the layouts and the configurations that are here, if they work with spinning disk, they're going to work extremely well with solid state and flash storage as well. So as you know, in our shop where you and I work, we've implemented all of these in all of our environments, and we use them very stringently, and it's worked out really, really well, whether we're running on flash storage or we're running on spinning disk. Most of our systems today are on flash storage, at least our heavy transactional based ones are. But let's get started. So, with automatic storage, I don't know what version, but we got these storage group definitions, and you used to create them at the database layer. Now you can just create the storage groups. We want to talk about those and what goes in those storage groups, using automatic storage for all databases you create, and then using the storage group to set the overhead and the device read rate, so that all of the table spaces within that storage group have those settings. Don't set them at the table space level, set them at the storage group level. That way you can control them in one place. So here we're recommending 4 storage groups. A lot of times the cat storage group and the data storage group are just integrated into one. People only create 3 instead of creating 4, and that's fine as well. But we're recommending you do 4: a catalog, a data, an index, and a temp. The temp is a system temp, obviously. The catalog is the syscat space. Data is for data, and index is for index, basically user data and user index storage groups. And again, we recommend that you set the overhead and read and write transfer rates at the storage group level, not at the table space level. And you can see here from our example on point 3, we're setting data as the default. So why do a default, Mohan? Why would you set one of the storage groups as default?
That will be the default, because whenever we create the table space, that has to go somewhere. If it is not set to default, then it is not going to create the table space anywhere in the table space in the database.
So yeah, so if a DBA forgets to set the stow group definition for the table space, it'll automatically go to data, right?
Correct.
Yep. Okay. We talk
And
we can
only have one default storage group within entire database. You can create multiple, but you can only set as one as default.
Yep. You don't only have one as default. You're right. I think that's alterable as well, right? You can alter and change the stow group that you want. If you set it to data and later you wanted to set it to index, you could alter and set the index to default.
Oh, yes.
Yeah, it's all alterable. One of the things in here that we do talk a little bit about is file systems with ranks and chunks, and all that stuff is still true as far as provisioning on the architectures. But I'm not going to spend a lot of time talking about this, because again, with flash storage and with solid state devices, a lot of this is the performance aspects associated with it are still good, regardless of whether you create many chunks or you create less chunks. But obviously, the rule of thumb here is the more physical disk you have in your array, the better the performance. The smaller the number, the less the performance. Now, again, that's relevant to spinning disk and to some slower disk. If it's 100% memory, then that's less of an issue or less of a concern. But again, like I said, if you build them a certain way, they'll perform well, regardless of whether they're all memory or whether they're spinning disk. But creating your containers based on the number of cores that your system has is also very important, right? Because concurrent IO and even direct IO, but concurrent IO, the DB2 is actually looking at, from a parallelization perspective, the number of physical containers, because it doesn't really bode well for you to issue a bunch of IO requests to a single file if that file can only service one request at a time. So you basically have a certain number that queue up on the device, and then you have the rest of them backing up in the OS as serviceable IO. So the more files you have, the more parallel IO you can execute. And so you're wanting to and get those executed through the system quicker, so that they're not in a scheduled state. They're actually in an executional state. We typically have because we're using usually something in the range of 6 processors and probably 24 cores or something like that on a system. We'll typically do 4 to 8 file systems, and we'll create containers across each of those. And we may create multiple containers per file system. So if we have 4 file systems, we might create 8 containers or 16 containers to increase the IO performance in a parallel scan-like operation where multiple IOs are required to return back the data. Again, index-only access is the best. unless you're doing direct access. Direct access says, go to the page, get me the load the page or get the page that I need and read the row off the page and I'm done. Index only access is the second highest, followed by obviously index matching. And then of course, table scans are things that you still want to try to avoid even in a solid state world. You want to get rid of table scan type of queries that are being executed. So in here, we talk about extents. We talk about the number of extents. We talk about if you're having heavy writes to a system, you know, using a pen mode, if your keys are sequential, using a pen mode is a smart thing to do. Your write rates will go up significantly. And then partitioning the table, if it's a large table and you're wanting to do many parallel writes. I mean, in some systems, we get upwards of 35, 36,000 inserts per second because we set up multiple partitions with multiple space map pages and multiple containers across a large amount of devices and issue parallel streams for writes in the application using Java. And we can get, you know, 50,000 inserts per second is not unusual. But anyway, another thing to do here on the database names is you've got a physical database name and you've got basically aliases in the DB2 world, right? And when your applications are connecting, they're connecting using a database name. And to make it easy so that they don't have to keep changing or building multiple configuration areas or files for each environment, if you have them just set to the alias name and you remove any kind of a duplicity in that alias name, so that, you know, DB1 is DB1 across all the environments, then the application team does not have to maintain multiple configuration files or areas with regards to the database name, right? And then the ports should be the same across all of your environments. The server will be the only thing that would be different in this configuration. It's usually the server name is, in our case, right, has like one letter different between the old server name and the in one environment, say in the dev environment versus in production. There's only one letter difference between them, so it's real easy to maintain and remember. But this is how the URL is set up. Is how to set up the mapping for the URL. I wouldn't do things like set the version number in a database name. I wouldn't set things like payroll, because then you can't really reuse that database for any specific reason physical without violating the name, obviously. You know, databases they're basically containers to store data for multiple schemas. And you could think of a schema as a logical database. So a physical database is a big container. Then within that container, you've got logical databases, which are schemas. And so you could put many applications or products within the same database, as long as you use and make it make sense, as long as you're using an esoteric type of name for databases. In our case, we use DS for data sharing, which tells us if we see a DS for the first two letters, that's a data sharing. It's a cluster technology that's being implemented. If we see DN or DB, I mean, then that means it's non-shared. Means it's a standalone LUW environment or an HADR configuration, but it's a standalone single primary system, non-clustered. And then we'll use letters like DP and T for development, production, and trial. And then just a sequence number as we create multiple databases. Again, when you're creating security rights, I mean, obviously DB2 is moving more toward being able to set generic rights at the schema level instead of at the object level. That's something that was tested, I believe, in or considered for 11.5, and I believe they've implemented that, so that there's certain things you can do at the schema level now. We don't talk about that because this is a 10.5, 10.1 certification book, but using roles for your security, setting your most, your highest level of access rights per user or group, so that you're not giving additional rights to groups that they don't need, but you're just giving them the rights that they do need. So if you've got a group that does backups, then give them access to be able to do backups only. If you've got a group that is able to set up security, then give them security rights only. Restrict access to data to those that have to have access to the data. Use roles instead of defining actual grants to objects, but set up a role and set up the rights to that role, and then set up access to those roles. Set up roles based on usage needs, right? Applications can use esoteric accounts to connect to the database. Those rights would only need to be granted to the role for that ID, specific for running that product or application. If that is a read-only application, then it only needs read access to the structures. If it's an application that writes and reads, then it needs reading and writing to the different objects. What catalog tables need access to? I know that in our environment, for example, we restrict access to any catalog table that ends in AUTH. Those are things that are specific to the company, but I think they're good ideas. They're good policies to limit catalog access and only allow catalog access for those who actually need that level of access. I think, again, keeping these IDs up to date, keeping them clean, having the right ones in each environment set up and configured, disabling them if they have password violations or access violations of any kind. Monitor access to your SOX databases or SOX compliant databases, or where you have PII data. It's real important that maybe you have some form of security monitor that's monitoring all accesses to that data. Even the failed attempts to access it should be collected and reported. Those are just some security things that I think are good policies to follow with it when you set up your database and run and operate your database. Obviously, restrict the instance level account accesses, sysatom, even dbatom, down to dbatom. I would restrict those to only those groups and areas of your company that have that responsibility. Make sure that they're provided that right and that access only, and maybe even set up some type of audit process that can be run against your databases on a regular basis to secure and ensure that those access rights are being adhered to throughout your company. Again, in this section, we talk about application access. I think there's a couple of areas here that are real important that we started following that I don't know that we really explicitly talk about them in this section. But when your application connects to the database, there's an application name setting on the JDBC URL that can be set. And that application name is visible in the connection displays when you're looking at connection displays, and even when you're looking at WLM metrics and statistics. You can see the application name, and that application name can be used as you define thresholds and restrictions within WLM. You can use the application name to restrict it. What's nice about using application name is if you're in a microservice architecture, you can define each service to an application name and make sure that application name is unique. And then if you have any violations, you know exactly which service is violating your WLM settings. You can contact the business owner and the development owner and get those things fixed or resolved. If you have any runaway connections, you can quickly tell who it is. It's really hard to do it in a microservice architecture if you don't have that name, because you might have one connection ID that's being used by 100 different applications and services. I mean, in the modernization effort that we have underway where we work, there could be over 1,000 microservices easily running in a clustered environment. And if you don't have that level of delineation, it's going to be very difficult to be able to determine who to talk to about violations that you're seeing. Make sure that, and we talked about this earlier when we talked about the instance ID, make sure the IDs and or groups that you have set up are set up restricted, right? The accounts that are defined, esoteric accounts that are defined to each of these different instance level settings, we don't log into those. They're restricted. You can't log into them. You have to sudo to the account in order to be able to get access to it. I think that's important, running those as restricted accounts on the server in case someone ever did get in. It wouldn't help them because they wouldn't be able to get into the account. Running them as esoterics. I really want to stress using groups and assigning groups to roles, because groups give you a higher level of control. It also, DBAs don't really like to have to be responsible for knowing every account and who has access to what. That's usually another group. And so you can control through an external security tool, such as Active Directory or Temtam or some other tool you can use for provisioning groups and IDs and assigning those IDs to the groups, and let some other team be responsible for doing that. I mean, we basically do grant access for these IDs, and these IDs are set up on the Unix servers as unlimited with never expiring passwords. I think that's important because you don't want to lose a system because a password expires, or because a malloc request to a Unix server was denied, and DB2 really doesn't like making memory requests and being told no. But I think we need to reconsider that a little bit. We need to reconsider at least the unlimited across everything. It's okay to limit certain things. I wouldn't limit CPU. I wouldn't limit memory either, but I would limit other things such as files or dump size, or maybe some other settings that are on the Unix side that doesn't need to be unlimited. How we doing, Mohan? You following me, or are you asleep?
No, I'm following you totally.
All right. Things going okay? Can you hear me okay?
Yeah, things are great. A lot of information, a lot of great information.
Yeah, now in a clustered environment, and even in a non-clustered environment, you can use the db2 dsdriver.cfg file, right? And there's some db2 CLI INI file as well. There's some commands you can execute to validate your settings in there, right? I'm showing one here on the screen. db2 CLI command you can execute to validate a database and make sure that your configurations are set up correctly in the XML file,
right?
That it's actually right, and then it works. And you should see that it's success schema validation completed successfully without any errors. I believe that's still the message that comes back. You can put this dsdriver.cfg file on a server, and you can specify the path in a variable, shell variable, to specify where that file is located. If you put that file right next to the db2 jcc.jar file, or jcc4, whichever one you're using, jar file, it will pick it up and use it if it's there. Otherwise, you can, like I said, you can specify the path location for where you want to put it. And I believe you should specify a path location and put it in a place where DBA has ownership of it and responsible for changing it or setting it. There's a few other things that I want to cover that aren't in this section. As you can see, we just finished the section. I'm not going to go into detail about the dsdriver.cfg file. You get a template one that you can then increase or expand or change, modify any way you want to modify it, and add different things to it. If you're running highly available clusters, for example, then you've got groups and You can have a primary group, you can have a standby group, and you can have a DR group defined in here so that the connection will follow as clusters are shut down. If they are broken, it'll follow the connection to the last cluster if that's what it requires. You can affinitize in here. We don't do that in our shop today. We let workloads find resources, which in our estimation is one of the main reasons why we chose PureScale over other technologies that are available, is because unlike other technologies where heavy chatter between the application and the database is required in order to be able to run workloads, PureScale operates very, very efficiently and effectively, even when workloads float. So we don't affinitize in any of our 11 clusters. We allow workloads to find resources, which means they could run on any member in the cluster at any given time. But there could be applications where that's just not feasible, where the way they're architected and written, you have to do some additional affinitization to them just to keep them from having large negotiation times or reclaim times or space map issues where they're constantly reclaiming space maps on inserts and updates and deletes. So in that case, then you can use this file to affinitize workloads. You could also just use a straight DNS type of configuration to restrict them, right? You could basically state which servers they can run on, which servers they can't run on. Now, in the case of PureScale, if you specify a DNS with only one server, the workloads can still move because PureScale comes with connection load balancing as well as transactional load balancing. It won't load balance a stored procedure. If a stored procedure starts on member A, or member 0, I should say. Let's just say member 0. If it starts on member 0, it'll have to end on member 0. You can't split transactions up inside a stored procedure and run them on different members. But you can say Java transactions. So if you had 3 streams that were starting up and they connected to member 2, the connection was to member 2, and then the connection moved to say member 3, and the transaction started on member 3, when that transaction ends, the next transaction starts, DB2 can move that transaction to another member that has better resource utilization available to it, lower utilization specifically, and can allow workload to run across multiple members of the cluster. We're showing here enable ACR, and we're showing enable seamless ACR. That seamless ACR is just so you don't get that notification, that pesky is it 4498? I think it's, don't quote me, don't get me in trouble if I just told y'all wrong something, but I think it's 4498 message that says your connection has been moved. There's nothing you have to do, but we're just notifying you that your connection moved. If you don't want that message, then you can put that in there and it'll remove it. That alternate server list first connect is very, very important, because let's say you specify a server, let's say it's member 3, and your application goes to connect there. Let's say it's completely down, the port's closed, nothing's there, it's not pingable. You want to specify this so that it'll go to another server and try to connect. Otherwise, the application will just come back with an error message and stop. So you need to, the reason for that is that DB2's got to get in there, establish the connection, pull the metrics back to understand which members of the cluster are active and which ones and what their resource levels are before it can move you. So you've got to literally get connected. On first connect, you got to get connected first in order for it to be able to get that information. So, but a couple of other things that I want to go over, and I'm not going to have a slide for it, so you're just going to have to follow me here, but it has to do with application development, right? you can build the best cluster in the world. You can follow the DSFA guidelines here in Appendix A, and your applications still suffer whenever there's a disruption of service from the database. In order for you to achieve full DSFA, you've got to set certain guidelines and certain principles about how applications are designed and developed. Just like in an HA configuration or a DR configuration, if you don't have connection retries logic, if you're not setting up your try catch blocks from a Java perspective correctly so that the catches actually identify a disruption and not an outage and is able to retry, say, up to 4 or 5 minutes, then you're going to be constantly cycling applications, and those applications may not come back because the pools may not get reestablished. You could have all kinds of issues that require you to have to basically cycle the apps, and you don't want that. You want to be able to have disruptions of service and the applications continue to work and can work without any intervention by human beings or even automated processes. You just want them to keep working. And so one guideline, we just talked about something at the very beginning of this conversation today about how if your coding selects star, you're basically building applications that are no longer relational. You're building applications that are positional by definition. The same thing is true for DSFA. So let me give you an example. And when I say a fully qualified object, what I mean by a fully qualified object is an object with a period in it. In other words, it's a schema period view or table name, right? If you're coding fully qualified objects, then you're telling the database exactly which object you want access to. Well, in a relational database, in a relational model, it's possible for us as DBAs to now create environments where we can keep you never down. We can either use replication techniques or sidecar techniques or other techniques to create parallel environments for a temporary time period while you're running and operating. And then when we get those in a peer state, we can flip you to the target. And once we flip you to the target, then you don't even know that you've been flipped to the target. That might include adding columns, that might include restructuring of tables, that might include moving from one storage type to another storage type. It could, I mean, this could be lots of reasons why multiple schemas for an application are required. But what we're talking about here is two active parallel schemas. So you have payroll, let's just say, and payroll's running on a version 1 schema. And you've got some pretty radical tax changes you have to make to the environment. And to make those changes, you've got not only data value modifications you have to make, but you got structural changes that you have to make. And you don't want to disrupt payroll at all. You want it to stay up and running. So you create a parallel schema, a version 2 payroll schema. If your application that's accessing that schema is not fully qualified, then what happens in the database is when it connects to DB2, as well as Oracle, by the way, when it connects to DB2, it will use the connection ID. So it will come in with a default schema as the connection ID. We call those application schemas. The schema name and the application user ID is one and the same. So let's say it's payroll admin, and that's what the application runs under, is payroll admin. So it's going to come in, it's going to look for objects under payroll admin. Well, what you do there is you create what used to be called synonyms in some environments. Now they're called aliases, I believe, everywhere. You create an alias, which is a pointer from what the user ID dot table name is referenced in the code to the actual schema object. So before you created version 2, that would have been payroll version 1, and it would have went to table 1 in payroll version 1. Well, when you build this version 2 and you get it in peer state, now you're ready to switch them. If you have these aliases defined, you can simply change the alias to point to version 2. And now everything in the payroll app without cycling the payroll app, is now talking directly to version 2 of the payroll schema. And the beauty of that is, let's say you run it in a quasi-production validation environment first, that happens to be in production. Maybe you basically block users from accessing it and you only have certain test users that can get in there. You validate that everything worked perfectly well. And if it didn't in the cutover, then you just simply switch the aliases back to version 1 and the application is back running the way it was running before. So you have the ability to move them in within seconds. You have the ability to take them out within seconds and move them back. On top of that, if you create what we call a base view, think of a base view as being an exact clone of the table itself. If you build a base view for every single solitary table you create, and then for the aliases that I just talked about, you point them to the view instead of pointing them to the base table, now you have another extraction layer. That extraction layer is this view. Well, the views can have less columns if they don't need to be seeing certain pieces of information. They can have columns in different orders. They can be joins where you're joining multiple tables to form a result set that comes back. They can be filtered, as we just talked about a minute ago, by cost center or by user ID. But what the beauty of this is now a DBA can change the back-end physical table, and under most conditions would be able to do that without modifying the view if they use certain constructs, and we'll talk about that in just a second, right? Again, the DSFA would have to include, if you're going to add columns, do you add nullable columns or do you add not null columns? Now, if you add not null columns, do you require a default value for all of your not null columns? I mean, those are the kinds of things you have to put in as policies if you're wanting to be able to implement DSFA to its fullest, right? Because not null columns that don't have a default value would be pretty bad, right? Because that would mean the application would have to already be in place to facilitate that additional column.
Value, yeah.
Whereas, and really, Mohan, for us as DBAs, there's a simple question you can ask yourself. If you're looking at some changes you want to make to production, if you can answer to this question, yes, then you're DSFA. And that question is, can I make these changes without changing any application code or user access to these objects, and they continue to work? Can I change the physical schema 3 months before any applications that use those objects have to be updated? And if I can, then I'm DSFA. Right? Because if you've got to have the code in place at the same time you make the structure change, then you're not DSFA. Because that means you've got to coordinate not only all the application changes, but you got to coordinate the database changes at the same time. And you want to avoid that. I'm not saying that will never happen. I'm just saying you want to try your best to build the environment so that that never happens. Again, never code select star. We already talked about that. I think this is the 3rd time I bring it up. Don't ever allow that in production by anybody. Even an ad hoc user who's coding their own SQL through some form of a front-end tool, if they're wanting to save that SQL for any reason and reuse it in the future, don't let them code select star. Monitor all of your SQL coming into your system, and if you see those, especially if it's a relational database we're talking about, then remove it. All right. Now, we haven't talked about JSON. We haven't talked about graph. We haven't talked about HTAP, multi-model HTAP. We haven't talked about analytics and OLTP and data warehousing all coexisting within the same database. All of those things are possible, and all of those things are made better if you follow DSFA guidelines and recommendations. If you do that, you can truly reach a continuous operational state, even in the current database technologies that are available to you today. You can do it. Now, again, like I said, it may require some additional disk space to create sidecar objects that you have to keep in parallel using replication or some other technique until you are ready to flip over. It may require you use an external replicator of some sort, other tools that are available out there to replicate. It may mean having to be creative about some of the ways that you prepare for change in the environment, but you can reach a continuous state of operation. Mohan, you and I know we've got a system that from a database perspective, we had to cycle it just recently because it'd been up too long.
Yeah, right.
700 and something days without ever being cycled. Then we started seeing Unix level performance issues because we haven't cycled it. That's another thing to talk about from a continuous operational perspective. In the Unix world, the Unix systems are really not built, to be really honest with you. I mean, unless you just build them and don't do anything with them, just let them sit there. But if you're running application code through them and database and tools on that server, you really want to cycle them on a basis, and that might be 2 years. It might be 3 years. I don't know what that actual number would be. It would depend on your environment, but you're going to probably need to cycle them at some point. And that's another reason why we're looking at what I would call continuous DR or operational DR, where we run in a constant state of DR, and at the schema level, we can execute a DR and run that application on its DR frame for a certain length of time, maybe 2 weeks, maybe a month, and then flip it back. And that gives us an opportunity to cycle those servers while the other ones are the databases, even while the servers are while the application's actually running on the DR servers. But you know, there really is a lot to go over here to get to a continuous state. But the competition today for traditional databases, which in my opinion are technologically 20 years advanced beyond some of the legacy stuff. You know, a lot of these cloud providers are providing databases that are nothing more than just MySQL or Postgres under the covers, and they build these tools on top of them for managing the environment and to making things easier and to giving you the look and feel of a highly available environment without you knowing anything about how it's actually done under the covers. But DB2 has technology in it that is far advanced, that took years to develop. And I mean, the current SQL optimizer, right? The SQL optimizer for DB2 went from, you know, we used to have a couple of them, right? We had the CPU model, we had the IO model optimizer. Now that we've moved into the AI framework and into the AI world, and there truly are pushing artificial intelligence into the actual optimizer. A lot of vendors say they have an optimizer and they really don't. And if you're running DB2, you truly really do. That's the reason why we don't really have quote unquote hints. We have tricks about what we can do code-wise to make certain behaviors occur, but we don't typically have to go in and code hints into our SQL to get them to work properly.
Yeah, worst case scenario, we will use optimization profiles.
Yeah,
it's very rare.
Yeah, it is rare. And usually it's because of a design or an implementation of a design that some application team has built that makes it required, right? I mean, they're using some type of unique key logic or something of that nature that requires optimization to be done to prevent performance related issues because their design is is unique. Maybe they're using self-referencing objects, right? Or they're doing something which is not typical in a regular transactional model, for example. And they're doing things not normal, and so you have to create these profiles in order to get the performance right. But you know, again, running Blue, running transactional executions, and running document and graph stores on top of one single database has some huge advantages from a DSFA perspective, as well as from just an overall perspective, that most people are not really following because they're not technologists. I mean, the cost of ETLing data across different environments, and then the integration of that data across different technologies is a roadblock and a problem for companies that are leveraging different technologies for different purposes, not really fully understanding that the data in many cases has to be integrated. If you're wanting to really get some business value from a operational perspective, for example, you have to be able to integrate that data across all those different platforms, and the cost of doing that can be significant. In the case of DB2 with document store as an example, you can insert, update, and delete documents, JSON documents specifically, in a DB2 table just as fast as you can within a traditional, well-known document solution today. But the beauty of it is, within a single SQL statement, you can reference a section or an element of a document and a row of a table or a column from that same schema or from a different schema within that same database in the same SQL statement. So now you can join between documents and OLAP structures, or documents and traditional OLTP structures in the same query. I mean, there are some complexities of operating and running analytics and traditional OLTP in the same DB. But if you do it right and you set it up correctly, you won't have any issues, and it will run extremely well. We do that today, and we have a lot of analytics that are performed along with traditional OLTP in the same DB. And not only that, but that analytical environment can be set up for HADR as well, which, you know, in some of the older systems, that would be very, very difficult to do because of their size. Again, in the Blue world, a gig is a meg. You know, a terabyte is a gig. You don't require indexes. You can build them if you want to, but you don't require them. And then the compression is significant in a Blue environment. So you can store an awful lot of data in a very small amount of disk space. I kind of got off the track here a little bit talking about other features of DB2, but I hope that the people listening today have got a grasp of DSFA, and whether they are in full agreement with it or not, or whether they fully understand it or not. I want to convey to them this: if you're running multiple technologies in your environment, or you're looking at different technologies, you should leverage the technology that you know best and use the technology that you have in front of you to the best of your ability and to the extent that it will perform before you go and start looking for something else, because something else has a cost. Something else has a startup cost. It has a purchase cost. It has an integration cost. It has a staffing cost. It has lots of cost. And maybe that's required. Maybe a new technology is necessary. Maybe a different technology is required because of certain things that you're needing from a business perspective. And if that's the case, then I want to encourage you to go out and get the best technology you can get. But most shops that you and I have seen, Mohan, over the years, they have a technology such as Oracle or DB2, and they really don't fully understand all the capabilities of that technology. And if they did, they might find that they've got solutions sitting right there in front of them that all they have to do is turn on, and it will work, and it will do what the business needs, maybe with no cost whatsoever. In the case of DB2, a lot of what we're talking about here, from compression to JSON to REST API, are all free. There's no cost to implementing them. So I hope everybody enjoyed this. I look forward to the next video that we do, and the next session that we do, Mohan. And any questions, any comments?
Oh, it's great. I think going forward, let's do a FAQ sessions and kind of a small demo sessions for 10 minutes each. And then we'll post it for each topic. For example, how do you use automatic storage table space? How do you use time series and all that, right? So we can give a real time demo, and working examples. They can take it and then play it on their system, and then try understanding the concept, and then they can be better DBAs.
Yeah, we heard some things not too long ago about shadow tables. You know, shadow tables is in our book. We actually launched and set up a shadow table environment. Did an awful lot of testing with shadow tables. We certainly could show how to deploy and implement shadow tables, how to get them to work in an environment, as well as you know, we could do certain things about, because we were one of the front runners on Blue as well. We can show people how to implement that, execute that, and then on JSON the same thing, right? Setting up index structures for JSON, how they perform, and how to run a merge, and what does a merge actually do. We can show all that in a video. Yeah, I think we should do that. Make it much easier for everybody.
Great. Thanks, Ken, for your time today, and we'll come back again.
Thank you, Mohan. See you.